Okay, welcome back to what is my third and I'm like 99% sure will be my last video talking about why some recent analysis that has been going around the internet that claims to prove that there was widespread voter fraud or tampering with voting machines in Michigan really does not make any sense. There is a much simpler explanation, that explanation being that the data analysis is presented in a way that's essentially misleading, that the metrics they choose to present inevitably take the shapes that they've identified because math, not because of votes being transferred from Trump to Biden. So if you're new here, I'm going to give a quick rundown of what that was just one last time. If you're not new here, I'm going to put up the minute mark where you might want to skip ahead to miss some of the setup, but I'll try to go through it pretty quickly. I think this will be a really fast video. So let's consider this very simple world where we have Republicans and Democrats, R's and D's. Republicans choose to vote straight ticket with probability S sub R, that's S for straight, R for Republican, and those are represented by the squares. They then choose to vote individual candidate with probability 1 minus SR, and those are denoted by the triangles. Same thing for the Democrats on the right. Now, if you vote straight ticket, you are necessarily, if you're a Republican, voting Republican. That's kind of by definition. But if you go to the individual candidate ballot, you can defect. So we label the probability of defecting for a Republican to be PR. That would mean casting a vote for Joe Biden. And the probability that a Democrat defects, PD. That would be casting a vote for Donald Trump. Now let's switch one of those back just for simplicity. So we're going to switch that one vote on the Republican side back to Trump. Now the original analysis calculated this quantity below, the excess votes Trump, where they calculated the number of individual candidate votes over the total number that went for Trump divided by the total number of individual candidate votes. So that's just the percent of those individual candidate votes that went for Trump. That's just a measure of how Trumpy the votes were, minus this baseline value, which is the percent of all of the straight ticket votes that went to Trump, or just the Republican straight ticket votes. So on the first term here is just a measure of the percent of the votes that went to Trump using only the individual candidate ballots. And on the right is a measure of the percent of votes that went to Republicans based only on the straight ticket votes. And then you take the difference between those two and you get a number. So in this case here, in this simple example, we get 6/8 for that first term and 6/12 for the second term, which gives us an excess Trump vote of 25% or 0.25. Now it's pretty easy to see here why this doesn't make a whole lot of sense, at least intuitively, as a measure of excess votes. So in this case, if you were just to look at the figure above, how many excess votes do you think Trump has here? I would say it's 2, right? He sort of got these 2 extra votes from the Democrats. Those are really the excess above and beyond what you would expect. And so if we take the 2 over the 20 voters we have in this figure, that would be 0.1, not 0.25. So in some ways, this measure inflates what's going on. The other thing that's strange about this metric is this. If we move some of those Republican straight ticket voters over to be individual candidate voters, but don't change their votes at all. So in the previous case, we had 6 squares and 4 triangles on the Republican side. Now we have 4 squares and 6 triangles. Then we get a totally different number. So when we calculate this excess Trump vote, we now get 0.4. So despite the fact that none of the votes have actually changed in this case, only the distribution of Republican voters between straight ticket and individual candidate ballots, somehow this excess vote changes. So that's another clue that what they're plotting is very strange. In any case, what they plot is that excess Trump vote that I just described against that baseline. So here the baseline is the percent of the straight ticket ballots that went Republican. And so in this case here, which we have above, where we have the probability of choosing straight ticket if you're Republican, let's call it 0.4, probability if you're Democrat 0.6, and probability of defecting for Republican is 0, probability of defecting for a Democrat is 0.5 in this case. What we end up getting is the baseline value is a 0.4 and that excess Trump is a 0.4. And so that happened when we had a 50-50 split, Democrats and Republicans. We can try to calculate this for a bunch of different splits of Democrats and Republicans, say 20 80, 0, 100, etc. And maybe we'll end up with a line that looks something like this. In fact, we can do that on a computer, and here are several versions of what that curve looks like when you do that calculation. So in this case, the curve looks like this when you have 25% of Democrats defecting, 5% of Republicans defecting, and the probability a Democrat votes straight ticket is 40%, that 0.4, and the probability that the Republican goes straight ticket is 0.3. You can get curves that look like this when you just switch up those parameters. And you can get curves that look like this, which, not to put too fine a point on it, but that looks a hell of a lot like what Shiva got in his analysis that he used to say that this is evidence of widespread cheating, of moving votes from Donald Trump to Joe Biden. Again, we don't need to move votes. We don't need machines to be rigged to get this curve. We can get this curve under the simplest version of the world, where across all precincts, Republicans vote at some constant rate, or Republicans defect at some constant rate, Democrats defect at some constant rate, Republicans choose to vote straight ticket at some constant rate, and Democrats choose to vote straight ticket at some constant rate. It is literally just what these curves look like when you do the calculations as Shiva did in the original analysis. Okay. And so I got the data from Oakland County, Michigan, to try to reproduce what was done. And this is what it looks like. So this should be in comparison to the previous slide here. And I'd say they look pretty similar. I mean, they're not going to be exactly the same. I think the data has been updated since he or whoever else did the analysis. But we see the same pattern, right? We see it's relatively flat up below, say, 20% Republican straight ticket. And then it goes down fairly linearly, which again was used as evidence that these votes have been tampered with. Okay. And so the question I really want to address with this video is what happens if we use some other metric of the excess Trump vote that isn't quite so strange, for example. What will this look like? So again, when they calculated theirs, the excess Trump was the proportion of individual candidate votes that went to Trump minus the proportion straight ticket votes that went Republican, and the baseline was the proportion straight ticket that went Republican. Instead, what if we just did the total proportion of votes that go to Trump minus the total proportion of votes that are for the Senate candidate that's Republican, and the baseline is that total proportion of Senate Republican votes. One advantage of this is you don't need to differentiate between straight ticket and individual candidate votes. We don't have to worry about any of those weird effects where we don't change any of the votes, but just move people from one category to the other. So the question is, what will this function look like? So in this figure, I've plotted that blue line. That's what you've seen before. That is the curve we expect Shiva's plots to look like under the parameters that are listed on the top. If we assume that Democrats defect for the Senate candidate at exactly the same rate as they do for president, and Republicans defect at the same rate as exactly they do for the Senate candidate as they do for the president, then we get the red line here. So that C value you can see up in the legend represents how much less likely a voter is to defect for the Senate candidate relative to the presidential candidate. So this is, again, using this really simplified world. So in this case, Republicans would defect if they were individual candidate voters at a rate of 15% when C equals 1. They'll defect for the Senate candidate also at a rate of 15%. When C equals 2, they'll defect for the Senate candidate at a rate of 0.075 or 7.5%. In this world, when they defect for the president, when Democrats defect for the presidential candidate with probability 0.05, and when C equals 1, they also defect with probability 0.05, and they defect for the Senate candidate with probability 0.025, 2.5%. And so what we expect this analysis to look like is if we think that voters are defecting for the Senate candidates at exactly the same rate as they are defecting for the presidential candidates, then we expect to see a straight line, that red curve, or the red line, really. It's not very curvy at all. If we expect that, for example, they defect for the Senate candidate at half the rate that they do for the president, then we expect to see a line with a slight negative slope, but it'll probably look a little bit less steep than what we see for president. Now, for example, if we could consider different values for C, we could consider the idea that they defect much more or much less, etc. We're going to get different curves, but I think sort of getting some intuition, we'd expect something like the red or the green line in this case, because I expect that people are defecting for the Senate candidate at a much lower rate than they are defecting for presidential candidates, especially in this year when the presidential election is so contentious and publicized. So let's take a look at what we get when we plot those metrics using the real data. So again, this is data from Oakland County, Michigan. The blue dots are what we get plotting Shiva's baseline versus Shiva's measure of excess Trump. The purple dots are what we get if we plot excess Trump as the difference between the proportion of Trump votes and the proportion of the Republican Senate candidate's votes, and the baseline is just that Republican Senate candidate's votes. We essentially don't see much of a relationship. There is like a slight negative slope, kind of as we think would happen given this simplified world and what would arise there. But it doesn't look especially interesting. And so when we use a metric or we plot the data in a different way that's maybe a little bit less bizarre than the original way, we don't see much of an effect at all that would suggest really anything interesting is going on. And so I think I'll close here. I've said a lot more about this data and this analysis than I ever planned to. But I guess I'll close by saying, I think it's really cool how many people are digging into this data and are really interested in getting to the bottom of what's going on. I would caution that just because you find a pattern in the data that you don't expect, or you find some relationship, say this line that's in the blue dots there that was originally found, just because you can't immediately explain that pattern doesn't mean that it's evidence of voter fraud. It just means you can't explain that pattern. Inevitably, people will find many other different types of correlations, different types of patterns in this data that they don't immediately understand. And like I said, this is probably my last video. I'm not going to go track all of those down and try to explain them myself. I would just encourage folks that before they jump on that vote rigging train, no matter how much they want to believe that that's what's happening, to please consider the possibility that that's not it. Please try to consider what other mechanisms could generate the types of patterns that you're seeing, like actually go and investigate what other plausible mechanisms there are that could result in the patterns that you're seeing in the specific ways that you're choosing to plot the data.